So we're solving using matrix, which means we're using Gaussian elimination. So first we need to write this as a matrix first. 1, 3, 1, -2, 3, 4. And when we're using Gaussian elimination, our goal is to make 1, 0, 1, right? And it was to get some number here, number, some number. And we have to follow that order. We have to make this one first, and then we make 0 here, and then we make 1 here. So here we already have 1 here. So that one's good. So the next step is we need to make this 0. So what I'm going to do is that now here's row 1, row 2. Row 2 is going to be -3R1 plus R2. So I'm going to multiply -3 to row 1 and add to row 2, and that becomes new row 2. Okay, so let me do that maybe right here. So row 1 doesn't change, so we can just copy it. So row 2, I'm going to multiply -3 here and add to 3, which I get 0, which is what we wanted. I multiply -3 here, which gives me -3. -3 plus -2 gives me -5. Again, I multiply -3, that's what we're doing here, and multiply -3 here. -3 times 3 gives us -9. -9 plus 4 gives us -5. Okay. So then our next, so we have 1 here, 0 here, that's good. Now we have to make this 1. In order to do that, the row operation I'm going to do is, now row 2 is same thing as -1/5 times row 2. So then what we get is 1, 1, 3, row 1 doesn't change. 0, I multiply -1/5, which gives us 1. And this also gives us 1. So now that we have 1, 0, 1, which is what we wanted here, right? Just like this form. This tells us that, well, 1y equals 1. And x plus y equals 3. Well, 1y is same as y, so we know what y is. Y is, in our final answer, y is 1. When y is 1, what is x? Well, x plus 1 must be 3, so x is 2. So solution to this system's linear equation, this is the solution. And this is one solution. They intersect at this point. One solution. We're solving this equation, the system's equation, using matrix. That means we're using Gaussian elimination. So first we need to write a matrix first. 1, 2, 3. -1, 3, -2. 1, -1, -9. 8, -2, 9. So when we use Gaussian elimination, first we have to make it 1 here, 0, 0, 1, 0, 1. We have to follow this order. Okay. So first we do have 1 here, right? That means now we have to make this 0. And then make here 0, here 1, 0, and 1. So we have to follow this order. So that one is good. So we have to make this 2 a 0 by row operation. So what I'm going to do is row 2, for new row 2, I'm going to multiply -2 to row 1 and add to row 2. That becomes a new row 2. So let me write the matrix here. Well, row 1 doesn't change, so I'm going to copy row 1. Row 3 also doesn't change, so just copy from the previous step. And now here, I'm going to multiply -2 to row 1, which is -2, plus 2 gives us 0, which is what we wanted. Then -2 times -1 gives us +2. Add that +2 to this number right here, which gets 5. -2 times 1 gives us -2. Add to -1 gives us -3. -2 times 8 gives us -16. Add to -2, -18. So we have 1 here, 0 here. That's good. Now we have to make this 3 a 0. So in order to do that, I'm going to apply row operation row 3. Now row 3 will become -3 times row 1. I'm going to multiply -3 to row 1 and add across so that this will be 0. Plus row 3. So new row 3 will be -3 times row 1 plus row 3. So let's see what we get once we do that. So we get, well, row 1 doesn't change, so to copy it. Row 2 also doesn't change. So row 3, -3 to row 1. -3. -3 times 1 is -3. Add to here gives us 0. -3 times -1 gives us +3. 3 plus -2 gives us 1. -3 times 1 gives us -3. Add that to -9 right here gives us -12. -3 times 8 gives us -24. Add that to 9 gives us -15. So we're good with 1, 0, 0. Now we have to make this 5, this location 1. So here what we can do is we can actually switch location of row 2 and row 3 because we have a 1 right here, right? So we can switch the entire row, which is allowed in row operation. So row 1 doesn't change, so I'm just going to keep it 1, -1, 1, 8. Now row 3, entire row 3 will be row 2. So I'm going to bring that up, entire row 3, like this. And 0, 5, -3, -18, like this. Okay. So we have 1, 0, 0, and 1. Now we have to make this 5, 0. In order to do that, we need to multiply -5 to row 2 and add across. We cannot multiply 5 and add to row 3 because then this 1 will be adding to this number 0, which will not make this 0 anymore. Therefore, only row operation we can do here is that row 3 is -5 row 2 plus row 3. So let's see how that will look. Well, row 1 doesn't change, so just copy it and make sure you're copying it correctly from the previous steps. Row 2 also doesn't change, so just copy it. So let's do this. -5 times 0 is 0, add to 0 is 0. -5 times 1 gives us -5. Add to 5 gives us 0. -5 times -12 gives us +60. 60 add to -3 gives us 57. -5 times -15 gives us +75. Add that to -18 gives us 57. So then for the last row operation, we need to make this, sorry, not that one, this 57 a 1. So what we can do is we let row 3 equals 1 over 57 times row 3. So we have negative, everything else stays the same. Zero, 0, we divide by 57, which gives us 1. Divide by 57 gives us 1. So this tells us that z equals 1. Y minus 12z equals -15. X minus y plus z equals 8. So we already found what z is. Plug 1 here to solve for y. Okay. So y would be -12. Oops, sorry, not equals. So I'm going to plug 1 right here. That gives me y minus 12 equals -15. Y is -3. So we know z and y, then we can solve for x here. Well, then we know that x minus negative 3 plus 1 equals 8, which is x plus 3 plus 1 equals 8. Well, x is 4. So our final solution, they intersect at one point, 4 comma negative 3 comma 1, which this is x, y, z. Right? So this is our final solution. And this problem has one solution. For this problem, we're solving by elimination, not Gaussian elimination, just elimination. Okay? So that means we're not writing matrix. We're going to pick a variable to eliminate. Okay? So I'm going to eliminate y. That means I'm going to multiply 2 to second equation. So I get 2x plus 2y plus 8. Oops, sorry, not plus 8. Equals 16. And the first equation is 3x plus 2y equals 19. And what I can do here is we can add or subtract. In this case, we can subtract. Then 3x minus 2x gives us x. 2y minus 2y gives us 0 equals 19 minus 16 is 3. So we just solve for x because we were able to eliminate y. Okay. So we found what x is. Then we can plug in either of these equations to solve for y. And both of them should give us the same answer for y. If it doesn't, that means something's wrong with our x. So we know that 3 plus y must be 8, so y must be 5. So our solution for this problem is 3, 5. And it's one solution. They intersect at this one point. So we're solving this problem using elimination. So we have first equation, second equation, third equation. So first, we need to come up with fourth and fifth equation in general to eliminate a variable so that we can make two equations, two variables. For this one, the second one doesn't have x, so it would be very convenient for us to eliminate x using first and third equation. So let's do that first. Let's eliminate x. So on first equation and third equation. Well, I'm going to write down the third equation first. In order for me to eliminate x here with first and 3, this is 2x, so I need to have at least 2x or negative 2x. Either one works. So I'm just going to multiply 2 to the first equation. So I get 2x plus 2y plus 2z equals 12. Then I'm going to subtract. So I get 2x's goes away. So I have negative 3y plus 3z equals negative 15. And then what we can do, we can think this as a fourth equation. Now, here we don't need to create fifth equation because, well, at the moment, because we can eliminate, right, using 2 and 4. So using 2 and 4, using this one and this one, I have two variable, two equations. So I can eliminate either y or z to solve for one of them. Okay. So let's eliminate y so we can find z first. Okay. So 2y plus 5z equals negative 4. Negative 3y plus 3z equals negative 15. In order to eliminate y, we have to have at least same number. We can be different by sign, right? So I'm just going to multiply 3 here, and I'm going to multiply 2 here. Then I get 6y, so I'm doing this one right here, plus 15z equals negative 12, and negative 6y plus 6z equals negative 30. So then I can add these to eliminate y. Then I get 18z equals negative 42. Oops, sorry. 15 plus 6 is 21, right? So z is negative 2. So we found what z is. Once we know what z is, we can also solve for y, looking at second equation, right? Well, 2y plus 5 times negative 2 must be negative 4. So we can solve for y. 2y minus 10 equals negative 4. 2y equals positive 6. Y must be 3. Okay, so we got z and y. Once you know those two, we can also solve for x using either 1 or 3. So let's look at this one. Well, x plus 3 minus 2, since this is what y is, that's what z is, must be 6. So x is plus 1 equals 6, x is 5. So our final solution is 5, comma, 3, comma, negative 2. So this, oops, let me put in parentheses. So this is our final solution. And this problem is one solution. So we're going to decompose this fraction expression right here. So first we need to factor it, the denominator if we can. So this is x times x plus 1. So we can separate this into a over x plus b over x plus 1. So we need to find what a and b are. So what we're going to do is we're going to multiply x times x plus 1 both sides of the equation, also here. Well, for this one, this cancels out, right? So we have left with 3x plus 2 equals, let's see what happens here. Well, I have to distribute here. When I distribute the first one, a over x and x cancels out, so I have a times x plus 1. For the second one, x plus 1 cancels out, so I have b times x. So we have 3x plus 2 equals, let's distribute a here, ax plus a plus bx. 3x plus 2. So we don't change anything on the left side because it's comparing. Let's rewrite this together. Ax plus bx plus a. So this tells us that ax plus bx must be 3x. And a must be 2. Right? So this tells us that, well, a must be 2. And we know that a plus b must be 3. So we found what a is, so what is b? 2 plus b equals 3, b is 1. Right? So our final answer is that we're able to decompose this. Let me write it right here. This fraction right here is same thing as a. 2 over x, because a goes here, plus b was 1. 1 over x plus 1. So in fact, if you make a common denominator of these two fractions, add them together, you get this. So we can always check our answers on these problems. Partial fraction decomposition. First, we need to factor the denominator. 8x minus 42 over x. Oops, I already wrote x. I meant to write it right here. X plus 6, x minus 6. So that means we can decompose this fraction to a over x plus 6. I'm sorry, I meant to write minus 3 here. Plus b over x minus 3. Okay, so this right here is what we're going to work with, right? So on both sides of the equation, I'm going to multiply x plus 6 times x minus 3. X plus 6 times x minus 3. Well, these will cancel out here, right? So what I've left on the left side, let me just write it here to have more room. I have 8x minus 42 on the left side. On the right side, well, I'm distributing this to here and here, right? Well, for the first one, when I multiply this to here, this x plus 6 cancels out. So I only have a times x minus 3. So a times x minus 3. Plus, the second one, x minus 3, x minus cancels out. So I have x plus 6 times b, or b times x plus 6. We do not change anything to the left side. Left side, just keep it as it is. Distribute a, distribute b. We have ax minus 3a plus bx plus 6b. 8x minus 42 equals, let's put one of the x's together. So ax plus bx minus 3a plus 6b. So what this tells us is that ax plus bx must give us 8x. Right? That means that a plus b must give us 8, because ax plus bx, collect like terms, must give us 8x. And this right here, 3a plus 6b must give us negative 42. Negative 3a plus 6b must give us negative 42. Okay. So here we have two equations, two variables, so system's a linear equation. So in order to solve for this, we can multiply 3 here to get 3a plus 3b equals 24. Well, this one stays the same. Negative 3a plus 6b equals negative 42. We can add across to eliminate a. Right? Then I get 9b equals negative 18. So b is negative 2. If b is negative 2, I can plug b right here. Right? Well, a plus b must be 8. But b is negative 2, so a must be positive 10. So a is 10. So our final answer, remember, what we found is just this part right here. So we decompose this fraction expression. What we got is a 10 over x plus 6 plus negative 2 over x minus 3, which we can also write as x plus 6 minus 2 over x minus 3. Okay. These two are equivalent, right? So this is the correct answer. We decompose this fraction into two separate fractions. Decompose this fraction. So here we have a repeated roots. That means that x minus 2 factor is repeated, right, since it's square. So we can separate this into 3 parts, right? Well, we have a of x minus 1 plus b over just x minus 2 and plus c over x minus 2 square. So when we have repeated roots, we have to write it like this, x minus 2 and also the square one. So and then we multiply the least common denominator, the x minus 1 times x minus 2 squared both sides. Right? We multiply this both sides. Well, here this cancels out with this, right? So left side will only have 4x squared left. Equals, now let's look at when we distribute this here, here, and here. Well, for the first one, just x minus 1 cancels out, right? So we only have x squared, x minus 2 squared times a. So I'm going to write that right here. So I have a times x minus 2 squared. For the second one, when I multiply this to here, x minus 1 doesn't cancel out, so we have to keep that. And x minus 2, we only have one of them, so only one of them cancels out. So when I write it here, so I have b times x minus 1 times x minus 2. And for the last one, x minus 2 cancel with x minus 2. So I only have c times x minus 1. Okay. So at this point, once you come here, we have to multiply everything out. So 4x squared, don't change the left side. Ax squared minus 4x plus 4 plus b. This is x squared minus 3x plus 2 plus distribute this cx minus c. And now we distribute this a and b to each of the parentheses. We get ax squared minus 4x. Well, let me write a first. Negative 4ax plus 4a plus bx squared minus 3bx plus 2b plus cx minus c. So here I'm going to regroup them, rearrange them. These are all addition, right? We can rearrange x squares together. So ax squared plus bx squared. Let me keep the 4x squared here. And I'm going to write one of the x terms. This one, and this one. So negative 4ax minus 3bx plus cx. And without any coefficients. Oh, sorry, without any variable, without any x. 4a plus 2b minus c. Okay, so what we're doing is a plus b must be 4 by this. And all these three, when we add, we should be 0. And all this should be also 0, right? Because we don't have any x term. We don't have any just number constant term. So what I wrote here is that we can actually use this two equation to eliminate a, so we can solve for b and c. So add these two, then negative 4a plus 4a gives us 0, negative 3b plus 2b gives negative b, c plus negative c gives us 0, 0 plus 0 gives 0. So negative b is 0. That means b must be 0. If you know what b is, I can plug b here to solve for a. So a is 4. If I know a and b, I can plug a and b here to solve for c. So that's what I did here. Negative 4 plus times 4. Well, negative 3 times 0 gives us 0, plus c equals 0. So c is 16. So we're able to find these three values. So our final answer, let me write it right here, is that when we decompose this fraction, we got a is 4 over x minus 1. Well, b is 0, so we actually don't need to write it. I'm just going to write it as a practice. And c is 16 plus 16 over x minus 2 squared. So pay attention which denominator has a, b, and c, right? So again, we don't need to write this one. This is just 0. So we can write final answer is just x, 4 over x minus 1 plus 16 over x minus 2 squared. So if you find a common denominator of this and add this together, in fact, you get this.